In this tutorial, let's take a deep dive into the new RBDLab fracture method introduced in RBDLab 1.6. Under Scatter Methods, let's click on RBDLab fracture and add RBDLab fracture. And here, this is a Boolean fracture. And if you would like to have a single output in the target collection, we can check on the single output and give a name here. For now, we can just leave it as it is. And there we go. These are the cuts and the cutters. So the first is debug and fix. And now here we have the mode, which is in the cutters or the final result. Under cutters, we can actually see the cut planes here. So these are the cut planes. And under final result, we can actually see how the chunks are going to be formed. So initially, we can click on cutters to see how we would like the cutters to behave and adjust these parameters. And then while working, we can actually work with the final result to see the actual chunks. And here we have a color option as random and error. Let's take a look at this. So in this example here, let's say we change the color from random to error. And under certain conditions, we have chunks with errors. If we use this explode tool to check, and there we go, we can actually see that these are the chunks with the errors. Now we can actually click on Fix Problematic Cuts, and these errors would be fixed. There we go. By default, this is enabled in the add-on. So this is just to show the work done behind the scenes. So this is the mode between error and random. Now the color random works with the attribute color type here. Now let's head to distribution. Now there are two different kinds of distribution to create the chunks. The first one is random and the second one is grid. First, let's take a look at the random points distribution. Now random points distribution creates the cuts at random. Now this is defined by the density volume and the max points number along with the seed. So the actual number of cuts, if we head to cutters, is defined by the max number of points. For example, let's change this to 1, and we're going to have 1 cut, 2, and 2 cuts. Let's say 5, and we're going to have 5 different cuts. So max points number is the one that determines the number of cuts. Now density volume, if we were to have large number of cuts, then we need to ensure that we have a large density volume. If we limit the density volume, and let's say we have a huge number, then we are severely limited in the number of cuts we're going to get. So the max points number is not going to give proper number of cuts. So always ensure we have a higher density volume, something like 100, for the max points number to work correctly. And seed is the type of pattern. When we change the seed, we get different patterns. There we go. Something like that. And then we have cutter settings. Now the cutters mode can be planes or spheres. Let's take a look at the planes. Now here under planes, we have something called resolution planes, which is the actual resolution of these cutter planes. If we increase this to something like 20, we get more resolution in the cutters. So that translates to more resolution at the inside geometry of the chunks. For example, let's head to final result and let's explode and let's take a look. There you go. Now with a low resolution, there we go. That's the difference between high resolution and low resolution planes. And scale, we usually do not modify the scale. For thickness, we can adjust the thickness a little bit if we would like to have a gap between these chunks. For example, let's say a thickness of 0.01. There we go. We can actually see the gaps between the chunks. So we need to be careful when using this thickness value here. We generally don't go with higher numbers as the fractures are easily visible. So we usually go with something very small number. And then repetitions. Now let's get back to the cutters again. Now what this repetitions does is with the same base pattern underneath, we're going to get more number of cuts. Like for example, if we give repetitions of 2, we're going to get double the number of cuts with the same base pattern. Let's say 3, and we get triple the number of cuts with the same base pattern. So using repetitions, we can get more fractures in the areas where the initial fractures occur. It's like adding more detail to the fractured part. What we do is duplicate the existing cutters, but use a different noise pattern to generate new fractures within the initial fractures. So let's get back to 1. And what do we need to do if we need to change the base pattern? We can either change the max points number or the seed here. That's how we can change the base pattern of the cuts. Now, cuts probability. So what this does is let's go to final result as we can see it clearly. So here we can see that every cutter is cutting the mesh entirely. So let's say we would like to have some of the cutters not cutting the entire mesh, and that leads to more organic cuts. Then we can actually reduce the cuts probability. Let's say something like 0.45. Now we can see that this particular chunk is not cut in its entirety. There you go. So that's how we can get more organic cuts, and that's how we can use cuts probability. But please ensure we don't go below 0.4 for proper calculations. And there's something called cuts probability seed, and we can change the seed to change the cuts probability. And we generally keep it at 0 here. Chunk size limit. This is interesting. Let's say we have these many number of cuts, and let's explode. We can actually see that there are many small chunks right here and right here. So let's say we would like to limit the chunk's size. This is the option that we can use. Let's say, for example, we give a chunk size limit of 10. Then we can see that we can minimize or even completely eliminate all the smaller chunks. So this way, we can have bigger chunks in the first iteration of fracture and then repeat the process again for the second iteration where we can have smaller fractures, which we're going to take a look in detail in this tutorial. So that's the advantage of having the chunk size limit. It gives more control over how the chunks are fractured and their size and the inner material. Now here, we can actually choose the inner material. Now by default, we're just going to have a default inner material, and we can actually choose what kind of inner material we're going to have. And we can go to the shading tab, and we can change the shaders here. So let's say, for example, if you would like the base color to be white, then we can have it white. Or if you would like to increase the transmission, we can do so. And there you go. So that's how we can work with the inner materials. For now, we're going to leave it at default. There we go. And then UV map refers to the UV map under the object data properties. And reductor. So reductor is pretty important. Now let's say we head to cutters. So these are the cutters. Now, in order for these cut planes to cut the mesh entirely, we need to ensure that we have large cut planes. So these are the actual cut planes used to cut the mesh. To generate the cuts, we need planes to ensure that they completely intersect the geometry. For that, we use the bounding box and multiply that by 2, which will be the size of the cutting planes. The problem is that these planes are very large, and if we add resolution to the plane, we'll quickly have tens of thousands of polygons. The Reductor tool addresses this issue by using only the necessary part of the planes for making the cuts and deleting the rest. This in turn greatly reduces fracture time and computation workload. So that's the advantage of using the reductors. And planes transformation, we'll take a look in the grid points distribution system. And noise, here are the different types of noise parameters that we can work on. And if you are to use shade smooth, we can actually give it shade smooth right here. And here we have an option to automatically add RBD after fracture, but for now, we're not gonna add it. And then we click apply to apply these fractures. For example, let's click apply. And there we go. These are all the cuts that we can see. And here is the target collection that appears here. So that's how we work with the new RBDLab fracture method. Now let's take a look at a few more options under the random distribution. So let's head to RBDLab fracture, add RBDLab fracture, click OK. And here we can see that previously we've seen the cutters moved in planes. Now let's see spheres. Now here, let's say we give the radius of the spheres as 3 meters. Now if we head to the final result, this is how the fractures are going to happen. So this is another method to fracture the mesh. Now we can increase the subdivision spheres as well, but please make sure that we don't increase this beyond a certain point. So if we head to cutters and switch off the reductor, these are the spheres or the meshes used to cut the original mesh. So if we increase the subdivisions too much, then we're going to increase the resolution too much, and the computations are going to take quite a bit of time and resources. And we can increase the radius of the spheres as well, depending on what kind of pattern we're looking for. So this is another option that we can use to fracture the mesh. So this is with the random points distribution. Now let's take a look at the grid distribution system of fractures. Now let's head to RBDLab fracture and add RBDLab fracture and click OK. And let's change the points distribution to grid. And let's change the noise strength to 0 so we have perfect grid kind of cuts. Now here we can actually head to the distribution. Under random, we saw that this is controlled by the density volume and max points number, whereas in grid, we actually have cuts in the x, y, and z directions. Let's say in the z direction, we need 0 cuts, and in x and y, let's say we would like 5 cuts to match the pattern underneath. There we go. So this is how we can actually get the number of cuts. And we can actually translate the planes as well in the x or y. And then we can also rotate the planes in x and y. So in this case, let's give it 0 and 0. There we go. So this looks good here, but let's also take a look in the final result. Now, as we can see, some of these chunks are not cut properly. So we can address this by slightly changing the resolution planes. Something like that. There we go. We can either work with the resolution planes or slightly adjusting the noise or slightly adjusting the thickness to get perfect cuts. So in this case, we adjusted the resolution of the planes a little bit. So there we go. Now let's just explode and take a look. So when we take a look at the grid, There we go, perfect cut. So it matches the pattern underneath, which is what we wanted. Looks cool. So now that we have the pattern, we can uncheck Automatic RBD after fracture and click on Apply. And there we go. So these are all the chunks. So that's how we can get grid fracture. All right, now that we have the grid, let's select all of these chunks and let's add another fracture on top of these fractures. So let's head to RBDLab fracture and add RBDLab fracture. And this time, let's give a single output. And let's say iteration 2 and random. And click OK. Now here, we can actually decrease the max points. Something like that. And let's take a look at the final result. And there we go. So as we can see, we have more organic fractures. The grid pattern is fractured again with random patterns. So when we explode, there we go. We can actually see all the chunks. There we go. So these are all the chunks. Now keeping all of these parameters at default, let's uncheck Automatic RBD. Here, if you're interested in, we can actually limit the chunk size as well a little bit here. So let's say chunk size limit of 5. Or maybe chunk size limit of 2. There we go. Looks cool. And let's apply. And these are all the fractures. These are all the chunks. Now here we can clear the first target collection. And now we have the final target collection here. And let's head to physics. Now here we can add a ground here or by clicking on the plus here. And we can hide it as well. Let's head to RBD. Now here we have an option called Boolean fracture proxies. Now let's take a look at what these are. So let's uncheck the animations. And without creating any proxies, let's add rigid bodies. Let's take a look at what happens. There we go. Everything explodes. And the reason for that is all of these chunks are intersecting with each other. And we're using convex hull for the shape, which means that all the rigid bodies are going to explode. And that's what's happening. So that's the reason why we need to work with the proxies. So first, let's create proxies and let's use convex hull. And then for the proxies, let's reduce the size of the proxies to 80% of their size and click on Update. Now let's check on the proxy visualization. So this is with the proxies with 80% size. And now, as we can see that the explosion is minimized. There we go. So the chunks are not exploding as much. So this is with the original chunks visualization, and this is with the proxy visualization. Now here we can actually click on animations. And with animations, what we can do is we can start scaling the proxies to their original size. So the start indicates after how many frames the proxies need to start scaling back to their original size. And the duration indicates the scaling completes in how many frames. So here, let's say the start is 10 and the duration is 10. And let's click on Update. And there you go. Now we can see the difference. But instead of doing this, we can actually use activators and have more control over how the simulation happens. So let's uncheck with animations and let's click on update and we're back to the normal. Now let's head to kinematics and let's add kinematic to the target collection, which means that, and let's click on update. And there we go. So the simulation is kind of static now. Now let's head to the activators module. And with this target collection selected, let's head to kinematics and let's add kinematics layer for all of these chunks. So let's click on A to select all the chunks and let's click on add layer. Now let's add an activator and let's add a sphere activator. There we go. Let's head to top view and let's bring the sphere here. Now let's add keyframes to the sphere to generate a path where we want the destruction to happen. So let's click on auto keying and let's something like this. There you go. Let's take a look. There we go. Cool. Let's deselect the auto keying. And so now we have the keyframes for the sphere. Now let's take a look at some of these options under activators. Now here we're going to use single activation for each of the chunks and with a margin of 0.1. And we're going to scale the proxy as mentioned before. So in scaling the proxy, we can see that we have offset and duration. So the offset indicates after how many frames the scaling starts to happen, and then duration indicates the number of frames during the scaling operation. So in this case, let's select 15 frames as the offset and 10 frames as the duration. And let's click on auto range to generate auto keyframes. And under initial velocity, with the mode as random, let's give the minimum of, let's say, negative 0.2 and maximum of 0.5 in the x direction. So the chunks are going to move in within these limits. And y, let's say negative 0.4 and 0.8. And let's say z, we're going to give 0.4 to something like 3. And let's record the keyframes. And let's take a look at the simulation. And there we go. Looks cool. So let's hide the activator and let's see the original and let's head to the material preview and let's take a look. There we go. So that's how we can control the simulation using proxies. So that's how we can create destruction scenes using the new RBDLab fracture method. Hope you like this tutorial. Thank you and stay tuned for more tutorials.